Today we are going to continue with section 2.2 and 2.3 transformations of functions, example number 5. Example number 5. They give you a function f of x equals x plus 1 squared minus 2, and they graph it for you. So your vertex is negative 1, negative 2, negative 1, negative 2 is graphed for you. A value is 1, which matches. And they ask you to graph g of x, which is f of x plus 4. So notice that we covered this notation back on example number 1, but now we're going to do the opposite. Where this used to be your final answer, now we are going to make a change on this graph. So you need to decide, what does a plus 4 do to the graph? The plus 4 is going to shift it up 4 spaces. Now, ideally, we would like to be able to shift the entire graph all at once. Correct? Ideally, if we can do this, we just shift it 1, 2, 3, 4, but we can't. So what we're going to do, we're going to shift each of the points separately and then connect them afterwards. So therefore, this point is negative 1, negative 2, and we're going to shift it up 4, 1, 2, 3, 4. This point is 0, negative 1, and 1, 2, 3, 4. Negative 2, negative 1, and 1, 2, 3, 4. And now we can connect all 3 points, keeping it the same shape, and that'll be my new graph. But now I need to be able to come up with a new equation. And we don't want to come up with a new equation from the graph. We want to be able to deal with the algebraic aspect. So we need to be able to do it algebraically and graphically and make that connection. So what I'm going to do, I'm going to write down my function x plus 1 squared minus 2. And there's a plus 4 outside, so therefore I'm just going to add plus 4. So it works very nicely. It works pretty straightforward. We're going to call that your new function g of x is equal x plus 1 squared plus 2. And if we did it correctly, then it should match our new graph. Your vertex is negative 1 and positive 2. Negative 1 and positive 2 matches. Your a value is 1, and that matches as well. So therefore, that is correct. Letter B. What does the negative 3 do to the graph? The negative 3 is going to shift it to the right 3 spaces. So therefore, this point needs to be here, negative 1, negative 2, will be shifted to the right 3. 1, 2, 3. This point here, to the right 1, 2, 3. That point here, shifted to the right 3. And now we can make our shape. We're just going to make a problem, trying to keep it the same shape as before, because it only got shifted. The shape remained the same. And now I'm going to come up with a new equation. I'm going to write down my function. There's a minus 3 inside, so therefore will be a minus 3 inside as well. So therefore there'll be h of x equals x1 minus 3 will give me negative 2 squared minus 2. And if I did it correctly, then it should match my graph. My vertex is 2, negative 2, and 2, negative 2, perfect. My value is 1, and it still matches. We're going to come back to letter C in a few minutes. We're going to continue with example number 6, A and B, and we'll do C for both. So try example number 6, A and B. What does the 1 do to the graph? And how about the negative 3? And we'll work on letter C together. Go and pause it, work on A and B, write down your equations, and then we'll check. Pause it. Excellent. So at this point, they give you the function f of x equals 4 square root of x plus 3 minus 2. So first, let's see, the starting point is not a vertex, but our starting point is -3 and -2, and your A value is 4, and that matches. So what does the +1 do to the graph? The +1 is going to shift it to the left one space. So therefore, this is to be -3, -2, shifted to the left one. This is to be -2 and +2, and shifted to the left one. And notice this is not really 5, but it's close to 5, so let's use that point as well. 2, 4, 5, and shift it to the left one, even though it's not a precise point. And now we need to be able to write out the equation. We have 4, the quantity square root of x plus 3 minus 2. There's a +1 inside, so I just add 1. That gives me 4, the square root of x plus 4 minus 2, and that is g of x. How about the -3? The -3 is going to shift it down 3. So this is to be here, 1, 2, 3. This is to be here, -2 and +2, and I'm going to shift it down 3. And that point 0, almost 5, 1, 2, 3. And now my graph looks something like this. It got shifted to the down 3. And now I'm going to write down my equation. Make sure I have enough space. And there's a -3, so I'm just going to subtract 3. That is h of x equals 4, the square root of x plus 3 minus 5. And that should match my graph. My starting point is -3, -5. 1, 2, 3, 1, 2, 3, 4, 5. My value is still 4, and that matches. Example number 5. C. So you need to think, okay, what is the 2 going to do to the graph? The 2 is going to be a vertical stretch. So we're going to stretch it. So you think about pulling. So now, one of the things that you have to remember is that f of x is the y. So we basically are going to multiply each of the y values by 2. So let's go and write down the point. This point here is located at -1 and -2. And I'm going to multiply it by 2. So now it's going to be -1, -4. 1, 2, 3, 4. It got stretched. This point here, it was 0, -1. I'm going to multiply the y value by 2, so it'll be 0, -2. This point here is to be -2, -1. Multiplied by 2 gives you -2, -2. And your graph got stretched. Should be a little thinner. And now I'm going to write down my equation. So I'm going to write down my x plus 1 squared minus 2. And that's multiplied by 2. I'm going to multiply my coefficient, which is 1, and the -2. When I multiply by the 1 by 2, that's going to be taking care of this number inside. So therefore, that will give me a 2 times 1 is 2, so I'll be k of x. 2, x plus 1 stays the same, and 2 times -2 is -4. And if we did it correctly, it should match your graph, where your vertex is -1, -4, -1, 2, 4 matches. My a value is 2, and that matches as well. So therefore, that's perfect. It is important that you do your graphical representation separately from your algebraically, and compare them and make sure that it works both ways. So try letter C for example number 6. What is the negative 2 going to do to the graph? It should do two things, right? Do you agree? It's going to reflect it on the x-axis and it's going to stretch at the same time. So go through the same process and see what you get. Go and pause it. So therefore, we're going to multiply. You got it? Excellent. So in this case, negative 2 is going to multiply the y value by negative 2. So this point here is negative 3, negative 2. I'm going to multiply the y value by negative 2, so it becomes negative 3 and positive 4. This point here was negative 2 and positive 2. I'm going to multiply the y value by negative 2, so it becomes negative 2, negative 4. And if we think about this value here, which is almost 5, 0, 5, it'll be 0, negative 10. 2, 4, 6, 7, 8, 9, 10. It's not really 5, it's about 4.9 something, but we'll treat it as 5. Just so it helps us guide our graph. So therefore, that is the graph. It got reflected on the x-axis, but it also got stretched at the same time. And now we're going to take the equation for the square root of x plus 3 minus 2, and we're going to multiply by negative 2. So therefore, that'll be k of x. Remember, you just multiply your coefficient and your last number, not 3, so it gives me a negative 8. The square root of x plus 3 minus 2. And if we did it correctly, it should match. Let's see, your a value or your starting point is negative 3, negative 2. Negative 3, negative 2 doesn't match. So what happened? Correct. Diaz did not multiply the last number. So if it doesn't match, you know that you did something wrong. It's negative 2 times negative 2 is positive 4. So let's see, negative 3, positive 4, negative 3, positive 4, that's correct. And my a value is negative 8, so it should be 2, 4, 6, 8. Perfect. So that works. So that's why it's important to do it separately so you can confirm that it works and that it should match every single time. So 7, they give you a function. First, what is the plus 1 going to do to the graph? It's going to shift it to the left one. So try to see what you get and we can confirm. We can check your answers. So therefore, we're going to shift it to the left one. So that becomes this point here, correct? And then the other two points are here and here. And let me use my ruler to make a nice graph. My equation, I'm going to add 1 to the inside. So therefore, that'll be g of x equals 2 absolute value of x minus 2 plus 1. And it should still match. My vertex is 2, positive 1, and it's there. How about the negative? What is the negative going to do to the graph? The negative is going to be a reflection on the x-axis. Remember, the y, f of x is the y, so we're going to multiply each of the y values by negative. So this point is 1, 3, so it becomes 1, negative 3. This point here is 2, 3, so it becomes 2, negative 3. This one is 2, 4, up 3, so it becomes 2, 4, down 3. So basically it just got reflected on the x-axis. And now we're going to write the equation. And we have 2 absolute value of x minus 3 plus 1. And we're going to multiply by negative. So it becomes h of x, negative 2, x minus 3 stays the same, and negative times a 1 becomes negative 1. And if we did it correctly, it should match my answer. My vertex is 3, negative 1, 3, negative 1, perfect. My a value is now negative 2, and it matches. How about for letter C? Try it, see what you get, and we can compare our answers. What is the negative going to do to the graph? It's going to be a reflection on the y-axis. So therefore, we're going to multiply each of the x's by negative. So it'll be 3 in positive 1. So now it'll be negative 3 in positive 1. Only the x values get. This will be 2 in positive 3. So now it'll be negative 2 in positive 3. And then the other point will be here. And now we need to be able to write down the equation. We're going to replace that negative, the x, with a negative x. So therefore, it'll be 2, or let me just write down my h of x. It'll be 2. Instead of the x will be a negative x minus 3 plus 1. And some of you will say, hold on, this, my vertex is negative 3 and 1. Well, not really, because we have a negative in here. So let's go and factor a negative 1 from those two. I'll factor a negative from both of them. I'll just factor a negative 1 or negative. So x minus plus 3. I set my absolute value plus 1 in my 2 here. Now, what's the absolute value of negative? It's positive. So therefore, this can be written down as 2, absolute value of x plus 3 plus 1. And now my vertex is negative 3, positive 1, and it matches. And we'll be doing this again on the next lesson. So h of x, so you want to keep that in mind, and we call it how we did it, so you can do it on the next lesson, the same process. So now it matches, and now it's correct. But if you left it on that form, it's fine as well, because you can now always simplify it. Example number 8. So now they give you f of x, where my vertex is 4, negative 2. 1, 2, 3, 4, negative 2. My value is 4. And so they give you the function and they graph it for you. And they're asking you to graph g of x, which is 1/2 f of x plus 3 plus 2. So how many different translations and transformations do we have? You have the 1/2, you have the 3, and you have the 2. So you have 3, and that's why I provide 3 graphs for you. So now, what should we do first? Well, just like when we do order of operations, we have to follow order of operations. So let's think about, instead of this, have 1/2. And we have, instead of x, let me place a number, so it becomes even. So let's place a 9. 9 plus 3 plus 2. What should I do first? The 1/2, the 3, or the 2? So we should add first, correct? We should do the 1/2 and then add. And then what should be next? Correct, the division or the multiplication gives me 6 plus 2. And then last, we're going to add the 2, so it gives us 8. So we'll be going through the same process. So first, the plus 3. So we're going to have f x plus 3. Then the 1/2. 1/2 f of x plus 3. And last will be the 2. So it'll be 1/2. x plus 3 and then plus 2. So first the 3, then the 1/2, then the plus 2. So first, what is the plus 3 going to do to the graph? The plus 3 is going to shift it to the left 3. So this point is to be 4, 2, and move it to the left 3. This point is to be 3, 2, to shift it to the left 3, and then that point will be here. So the entire graph got shifted to the left 3 spaces, but it should have the same shape, almost. Right? And now, let's come up with the equation. I'm just going to add 3 here. So that gives me 4x minus 1 squared minus 2. And it should match my graph. 1, negative 2, and it does. Now, the 1/2. We're going to modify this graph by 1/2. So therefore, we're going to multiply the y values by 1/2. The y value, this point is 1, 2, and multiply the y value by 1/2, so it gives me 2 multiplied by 1/2 gives me 1. So it'll be 1, 1. So this value is to be 1, 2. Multiply the y value by 1/2 gives you 1, 1. This is to be 2, 2. Multiply the y value by 1/2, so it'll be 2, 1/2. This is 2, 1. So if you multiply this is to be 2, 2. Multiply the y value by 1/2 gives you 1. And the same thing here. So now it got a vertical shrink. And now we're going to move, well, let's come up with the equation. We're going to multiply this by 1/2. So it gives me 2. X minus 1 squared multiplied by 1/2 gives me negative 1. And it should match 1, negative 1, 1, negative 1. And my a value is 2, so it still matches. And for the last one, we're going to shift it up 2. So this point is to be here, and 1, 2. This point is to be here, and 1, 2. And the other point. So therefore, that is my new function. Let's come up with the equation, and then we'll check on decimal just to confirm. We're going to add 2 to this number. So therefore, my function, g of x, will be 2x minus 1 squared, and add 2, so it gives me plus 1. And it should match. My vertex is 1, 1, which it is. My a value is 2. Now, if we go into decimals, and I type in my first function, f of x equals 4. You can also do this on the graphing calculator, but sometimes decimals is a little faster. To power 2 minus 2. And that's not uppercase, should be lowercase. There you go. And I'm going to type in g of x. First, I'm going to type in as what they give me, 1/2 f of x plus 3 plus 2. And I'm going to type in what I got. And notice that it matches. Okay? I'm going to give you all those points here. Questions? So that confirms that it matches our graph on the, and we can zoom in if you want. It matches our graph, and it graphs our function, and it just gives you all those points because of the intersections. Example number 9. So on number 9, they give you, once again, they give you f of x. They graph it for you. So my vertex is 2, positive 1. My value is 1, so it does match. You need to be able to come up with the function of g of x equals 3 times f of x minus 1 minus 2. Notice all the brackets. So what should I do first? Go ahead and think about it, pause it. What should be your 3 steps? So first should be the -1, correct. Then, because of the brackets, we have to take out the -2, and then last will be the 3. Go and try it, pause it, and then we can check afterwards. Work on all 3, and I need the equations below. Pause it. Excellent. So first, I'm going to take care of the f of x minus 1. So therefore, I'm just going to shift it to the right one space. So this is to be here, not here. And then the other 2 will be here. Now I'm going to subtract 1 in here, so therefore that will become x minus 3, not bracket, but not parentheses, but absolute value, and plus 1. And if I did it correctly, it should match, so therefore that'll be 3, positive 1, 3, positive 1, perfect. My value is 1. Next, I'm going to take out the -2. So therefore that'll be f of x minus 1 and minus 2. So therefore I'm going to bring this down 2 spaces. This used to be here, and 1, 2. This used to be here, so now here and here. And now my equation, I'm going to subtract 2 from here. So now it's going to become absolute value of x minus 3 minus 1. Positive 1 minus 2 is -1. And it should match. 3, -1 is my vertex, 3, -1 is my vertex, and my value is still 1. And the last, we're going to multiply by 3. So now it's going to be 3, bracket, f of x minus 1 minus 2. So each of the y values can multiply by 3. This is -1, so now it's going to be -3. This is 0. 0 times 3 is 0. This is 0 for the y value, so now 0. So now each of the y values can multiply by 3. And I'm going to multiply the coefficient by 3. So now it's going to be 3, absolute value of x minus 3. And let me multiply this by 3 as well. And that'll be g of x. And it should match. My vertex is 3, -3. Matches. My a value is 3. So therefore that is correct. And for the last one, they give you f of x. They need to graph g of x. Notice that this is 1, -1, -2, -1, -3. So let's fix this. That should be a 3. And my a value is 1. So now that is correct. So that matches your graph. And how many different transition transformations we have? We have 3 once again. Let's take care of the -2. Let's take care of the -1. And last will be the absolute value. See what you get, and then we can compare our answers. Go ahead and pause it. And make sure that you change that to a 3. Excellent. So first, my -2 is going to shift it to the right 2. So this will be f of x minus 2. Shift it to the right 2, so this will be 1, 2. This to be here, 1, 2 is here. This one's here. This is to be 1, 1. So move it to the right 2. This is to be -3, 1. Shift to the right 2. This one gets shifted to the right 1, 2. That one gets shifted to the right 2. So now it's the same shift, you just got shifted to the right 2 spaces. Let's write down the equation. We're going to subtract 2. So that gives me x minus 1 squared minus 3. My vertex is -1, positive 1, -3 now. Positive 1, -3, it matches. Next will be the -1. It will be f of x minus 2 minus 1. So now we're going to shift it down 1. And everything gets shifted down 1, so it makes it easier. And if we did it correctly, it should match the equation that we'll come up with. See the same shape? It just got translated, did not get changed, it just got moved. So now I'm going to subtract 1 from the outside, so therefore this will be x minus 1 squared minus 4. Now the absolute value. So that is the question. What does absolute value do to the graph? What is an absolute value? Absolute value will make all the negatives into a positive. So therefore, if we have all those values that are negative, all those values will become positive. So if we overlap it, all those, the absolute value means that all those negative become positive. So that's going to be your new graph, the one in red. So therefore, this point stays the same. That point is 3, 0, stays the same. And this part of the graph is exactly the same. This part of the graph is exactly the same. This used to be a 0, negative 3. Now it's going to be 0, positive 3. This used to be 1, negative 4. So this will be 1, positive 4. 2, negative 3. So it'll be 2, positive 3. And now it's going to be, that'll be the new graph. But to write down the equation, we're going to say g of x. And we're just going to take the absolute value of x minus 1 squared minus 4. We can simplify. And we can actually confirm on decimals. Let's type in the matches. Now this will be correct. So that's what we got. Notice that all the negative values became, if I just get rid of the absolute value, all those negative values become positive. So that is the lesson for today. Have a great day, and I'll see you guys next time.